talk to this in years past. I think it was 2 years ago was the last time I was with you. This is something I do pretty much every year for multiple different wine regions, but not only in the United States, in the Western US mostly, but also in other places in the world. And what I've been doing is I keep track of the climate throughout the year, try to note specific things that are going on, and discuss issues surrounding kind of how weather and climate affect us in terms of agriculture, but specifically in viticulture and wine production. So I'm going to be doing something similar to that today. My overall, if I can get my, there we go. I'm going to talk largely about the perspective from a global to regional framework for 2020. Very interesting year in multiple different ways. Hopefully we can talk about some of this and maybe lead into some questions that potentially will be looking back at 2020, but also forward to 2021. I have some current condition information, and then we'll look at a little bit of a forecast. So the very first piece of this is to kind of go into this, as I said, this global to regional perspective. This is a map of our temperature differences for 2020 from the most recent 30-year climate normal period. Globally, this is put out by Copernicus in Europe. It's one of the better agencies producing global data out there. You've probably seen in the news, 2020 was tied for the warmest year on record. There have been a few agencies that said it was just below the warmest, but it's pretty much right at a tie. 2.3 degrees Fahrenheit above average. 2016 was the other year it's tied with. And then the last 6 years together have been the warmest that we have in our data record, going back 150 to 200 years. 2020 was also the warmest year ever in the world's oceans. The upper 100 meters of the world's oceans has recorded its highest temperatures globally averaged overall. We also know that 2020 had the Arctic seeing its warmest year ever on record, and both poles continue to lose ice mass at record paces. And I want to highlight a couple of things on this map here real quick. First of all, this colder zone over parts of inland North America, this has been quite influential, I think, in some of the things we've been seeing, even in Idaho. And we'll talk about that, and I'll show some other things, another map that'll detail a little bit better, but also the very dramatic difference between the extreme warmth over the Siberian Arctic versus over the North American Arctic. Siberia this past year, talk about variability. In the summer, they saw a week of temperatures above 95 degrees Fahrenheit and even days over 2 days over 100. And then early in the winter, in December, they had temperatures at 75 degrees Fahrenheit below average. So dramatic differences between locations, and that'll become evident in something else, as I said, we'll talk about in a minute. In the continental United States, we had a above average year in terms of temperatures. It ranged from 0.7 degrees Fahrenheit to 4.2 degrees Fahrenheit above average. And you can see the general pattern here. The fifth warmest on record at 2.4 degrees Fahrenheit above average wasn't the US's warmest year, which is 2014 and then 15, but it still was a top five. 24th consecutive year that the continental United States was above average, and minimum temperature was up slightly more than maximum temperatures. I'm going to talk about that as well a little bit more, but it has to do with more moisture in the atmosphere. You can see the general pattern here that over parts of the Midwest and Mississippi River Valley, it was just slightly above average or near average. Versus up in the northern plains, also a little bit closer to being slightly above average or near average. If you look at precipitation for the United States in 2020, quite a big difference from a couple of the previous years we've had. For the continental United States, we were slightly wetter than average, but there were large differences across the country. The Southeast and Mid-Atlantic were way above average due to a record-breaking tropical storm season. While the Four Corners region, parts of the Rockies, the Plains, and California were way below average. And the Four Corners region has been this prolonged area of very dry conditions. In 2020, basically didn't even have a monsoon season. And then the first half of the winter has been almost no inputs whatsoever. So it's been real dry continuing, and we'll see that again when we look at some drought issues. I thought I'd show you some information about Idaho. Again, you guys live there, you work there, you know what 2020 was like. But this is some data going back to 1895 for what's called Idaho Climate Division number 5, which is the southwestern valleys area where most of the vineyards and production is in Idaho. And you can see the data here, just to give you some averages with it. If you look at 1895 to 1980, the average growing degree days was 2,400. Now remember, 2,400 represents the spatial average throughout that number 5 zone here in this map, which means it also brings in some higher elevation and cooler areas as well. So it's hard to compare that to maybe one location that's one of the warmer locations within zone 5, but I think you get the idea that we're just trying to capture something we can look at over time. So 2,400 degree days for that longer period there. And then when we go to our 1981 to 2010 average, it was 2,592, so about 150 units more. 2020, where the green star is, was 5% above our 30-year average, but substantially below the peak in 2015. The last few years have deviated from the broader Western US trends. I'm going to talk about that again here in just a moment. But the idea is that the vast majority of parts of California, Oregon, and Washington have seen all of their temperatures in the last few years up in this zone up here. But Eastern Washington and Eastern Oregon have been more like Idaho. The other component of this, there's relatively large year-to-year variability in degree days, heat accumulation in the region. A lot of this is driven by things I've talked about previously, how the Pacific is in certain decadal kind of oscillations in terms of temperatures and circulation, how the El Nino Southern Oscillation is operating, and then also this issue of the Arctic Oscillation, these big fluctuations that have been happening within the Arctic zone. And this past week was really a great, amazing evidence of this with the record cold temperatures all the way down into Texas. So anyway, I wanted to show you a little bit about that because I think that's very important for the inland Pacific Northwest, Idaho specifically. This is just one example. This is the temperature departures from average for March, April, and May of 2020, just to show you the pretty dramatic difference between the Canadian Arctic and the Siberian Arctic in terms of overall temperatures. We're talking about areas that are really ranging about 10 to 12 degrees Celsius difference between these two geographic locations. And this is what I mean by the Arctic going through some oscillations that have produced this, which is a very interesting signature for parts of the upper northern plains and even leaking over into parts of the Pacific Northwest, seeing kind of more average to even slightly cool temperatures from time to time overall. So this Arctic oscillation has become a pretty important player for us. This is also Idaho Division number 5 annual precipitation from 1895 to 2020. And of course, I think the first thing you can see there is there's really no trend. There's a lot of variability. The blue bars are each year to year. And then the black line is the decadal average. So you can see there was some periods in which it was a little drier than others, but not a lot of real dramatic differences to extreme droughts, although we're in a drier period right now. The 1895 to 1980 average is 13.7 inches, again, averaged over the climate zone number 5. And then 1981 to 2020 average is 14. So the more recent average is not much different than the longer term average overall. 2020 was slightly below average, both on an annual and water year basis within this basin. And years commonly vary by about 2.8 to 3 inches over this time period. And there's relatively larger year-to-year variability, again, driven by a lot of what's happening in the Pacific. And again, we'll talk about that here more in just a minute. So just some observations. I'm really making these few observations here relative to the entire Western United States because they really do hold pretty well. A little difference from place to place, but probably the first signal that we had for the year was really that we had persistent drought conditions that had carried over from the previous year. And we're still in some issues with drought. I'll show you those maps here in just a minute. We also had major temperature swings in April through June. And I know this occurred up in Idaho, but it also occurred throughout Oregon, Washington, and California. Major swings between cool and heat events. Matter of fact, in May, there was a heat spike in late May that was that came on the heels of some cooler temperatures and rain. And then there was also rain during bloom to set for many locations. Places in Washington and Eastern Oregon, a little less so, Oregon, quite a bit so, and possibly for you guys as well. We also had 3 major heat dome events. And what I mean by this is large areas of high pressure that set in place that brought us some pretty extreme temperatures. One of them was in late May, one of them was in mid-August, and then the other one led to our Labor Day wind event that occurred and of course generated fires and smoke as you've seen. But there was only moderate heat stress in 2020. And I think the real signature with this is that vapor pressure deficit or humidity levels were a little bit higher. And so that kept maximum temperatures lower than they would have been otherwise. And so that was clearly something I think that showed out for 2020. And we've seen kind of this ongoing trend with that having higher humidity and lower maximum temperatures. So if we take that and we go to current conditions, and I always like to look out at the Pacific. This is data from Saturday. And you can see here we got this broad pattern in the Pacific where it's warm in the north and cold in the tropics. The North Pacific continues this, as I said, warmer than average temperatures. It's displaying what's called positive Pacific decadal oscillation conditions, which means it's just we're getting more moisture into the atmosphere. It's feeding some of our potential for rain and snow events, but we'll talk about the spatial issue of that here in just a moment. We also have to go down to the tropics, and we can see that from the fall till right now, we transitioned pretty strongly into a La Nina condition. And this is expected to stay until spring, maybe early summer. Now, if you take these for what they're worth and look at them in terms of what kinds of winter conditions we should expect, we would expect the northern tier of states and up into Canada to be relatively cold and wet. We would expect the southern tier of states, California going across, to be cool and relatively dry. Now, that's a typical what La Nina conditions are, but the challenge right now is that the North Pacific and the tropical Pacific are out of phase. One's warm, one's cold. And when that occurs, you just don't get quite the same relationship that we normally see. I also wanted to show you just how dramatic what the tropics had changed. This is data going from January 19th, 2020 through, and then another snapshot in January 17th, 2021. And you can see the dramatic plume of colder than average surface waters. This is the signal for the La Nina. And then really this is our much warmer than average waters out over the North Pacific. So if we look at kind of what our first half of winter looks like, and when I was just getting online here today, Moya said it's been a mild winter. Well, it really has. The first half of winter over the Western United States has been largely warmer than normal. You can see some areas of course, in the Northern Plains and parts of the Rockies and Four Corners area have been a little colder than normal. But interestingly, there's also this issue that elevated areas have had greater departures from average than lower elevation areas, meaning that our mountains just we haven't gotten quite as cold as we would like to see for snowpack development. Oh, and by the way, this is water year, October 1st through February 22nd. We've also seen a relatively dry start to the water year for most regions, especially everywhere south. The Pacific Northwest and parts of Montana, of course, and Idaho have seen some rain, and the winter is looking better than the projections were for it about a month ago. You can also see some areas in California that are now showing up as actually having a little bit warmer or a little bit more precipitation during the winter. This right here is essentially all one storm in the central coast and up in the Sierras that happened in late January. One storm event changed their water year today. We can also go from here and look at the current snow water equivalent map. I'll zoom into Idaho in just a minute, but this is snow water equivalents across the West. We're near average to above in most places in the north, not everywhere, but most places, and then down pretty much everywhere else. Prior to that one single event in January, all of California's watersheds here were showing about 40%, 50%. Now they're at least in the 70s. But you can see down in the Four Corners area and some other areas here where it's been continued dry conditions. As I said, if you zoom into Idaho, you can see that currently right now in our snow water equivalent framework, we're mostly above average, except for some of the interior areas here, where it's below average by about 10 to 15%, or even up to 30%. I've also put in here the Boise Basin total snow water equivalent. You can see in the black line right here, it's basically running pretty close to average overall in terms of overall snow water equivalent in the area. Still got a long ways to go. The peak typically in snow water equivalent occurs sometime between mid-March and early April. So we do have some time to recover and build the snowpacks. And I think the Pacific Northwest has a much better chance of doing that than does California and points south. This is the current US drought monitor image. And everything you see here, anything in white on the map are places that are not in current drought declarations, and everything from yellow to the darkest colors go from abnormally dry to exceptionally dry. Currently, right now, if you look at just the Western US, we have a large footprint for drought. We've had this for about a year and a half, 2 years now. 90% of the region is in some level of drought, while 50% is an extreme to exceptional drought. And a lot of that is down into the Four Corners area, but there's still quite a bit of California and Oregon there as well. The Four Corners is the most long-lived. It's been like this for about 2.5, 3 years now. And the Pacific Northwest is seeing some recovery from the summer. Previously, all of the white areas in northern Cascades, Washington, Idaho, all of those areas were in abnormally dry conditions just a month ago. So, so taking all that information and trying to put it into a broad kind of summary and forecast from what we've been talking about. First of all, there is substantial variability in weather and climate factors going on out there, and I really expect it to continue. A warmer climate tends to breed more variability, and we've been seeing this. Many events have, the frequency and occurrence have changed over time, and so I think that we should expect that to continue. Also, the climate system has persistence, meaning that when it's warm, we're in a warm period like we've been, we would expect the climate to stay warm unless there's some major perturbation that causes it to flip backwards. So persistence in the climate system points to continued warming. This is data out of Berkeley Earth, looking at their record from 1850. They're pointing to the most likely range being in this green zone here for 2021. And you can see that we're likely to be somewhere in that top 10 overall for 2021. The one wild card that is out there is that the tropical Pacific is quite cold right now. And whenever the surface waters there over that large basin in the tropics is cold, it can lower temperatures some. But most people are saying that it's not likely to be as much as we would anticipate, but still keeping it out there as a wild card. Weather and climate extremes are forecast to continue at near record numbers in the US, and we've already seen some of that this winter, and I think it's only going to continue. The spatial extent of drought has increased, and especially in the West, I think we're going to see a little bit betterment going on in the Pacific Northwest, but this spatial extent is likely to be with us for a while. This warming Arctic, and again, this whole kind of framework behind one area of the Arctic being extremely warm and another being cold, I think we're seeing a situation where we're getting these warm areas that is producing mid-latitude climate variability that has been with us for a while now, and I don't see any reason why it's going to slow down anytime soon. The warmth of the North Pacific has given us a little bit more moisture in the atmosphere. I'm not talking about a lot, but just enough humidity level changes so that nighttime temperatures go up a little bit while daytime temperatures are muted just a little bit. And we're talking probably a fraction of a degree, but in some areas it's more prominent than others. The other component of this is higher humidity levels do drive disease levels, especially for powdery mildew and other moisture-driven diseases. If we look at the seasonal drought outlook going through the next 3 months to the end of May, everything in the brown here is from the U.S. Drought Monitors considered to be areas in which drought will likely persist. You can see that covers a large area of the West. You can see parts of the Pacific Northwest are seeing conditions that are a little bit mixed. That kind of inland area in Idaho and Montana is thought to continue, while there's been some areas where in Oregon and parts of Washington where drought remains but is projected to improve, or it's going to likely remove completely from the drought outlook. So we have a prolonged kind of issue of drought in the West, maybe some better conditions in the Pacific Northwest. Just wanted to put a short-term forecast into this. We've had our coldest air pretty much to date over the past 10 days or so. This cold air mass is likely to continue in the Western US over at least the next week to 10 days. There's going to be a little bit of recovery in the East, and especially down in Texas where they sorely need it. But we're likely to stay a little bit colder than average overall. If you look at moisture, this is accumulated precipitation from the 19th of February to the 26th of February. And you can see that we have a fairly consistent plume of moisture coming into the Pacific Northwest. So we should be building snowpack in the Cascades and then the Bitterroots and other mountainous areas, Blue Mountains in Eastern Oregon. However, everything to the south of the kind of the northern California-Oregon border is likely to stay dry. And I've even seen some forecasts showing nothing whatsoever from the border southward. So there's some concern still. If you look at the actual forecast map for that, The likelihood of being below average is much greater for, as I said, that Southern California, central to Southern California and desert Southwest. Well, we're likely going to continue seeing a little bit more moisture, at least through the short-term forecast. So taking that and putting it into a final forecast summary, we think that the tropical sea surface temperatures are likely to stay in La Nina until late spring, early summer. We know that the Pacific Northwest conditions are warmer than average, and there's no indication that that's likely to change. If you put those kind of all together and you look at the forecast models that are deriving from those conditions, they're all tilting the odds in favor of the Pacific Northwest, both coastal and inland, having near average temperatures late winter through spring. What I mean by that is more or less through April, early May. We're likely to see a wet rest of February and into March, and then likely turning dry. All of the forecasts are saying we're going to turn dry in the later portion of the spring. California is warm now and will be through spring, and they might see some average late winter precipitation in the north, but likely dry everywhere else all the way through spring. Frost frequency, which is always a concern as we're sitting out there. We just pruned our vines here on campus yesterday. Everybody's thinking about this at this point. Spring frost frequency and severity over the entire West tends to be somewhat moderate in years like this. And I'm using information based upon what I'm seeing in the broader perspective of the mid-latitudes right now. The probability of frost, later frost increases northward and further inland, just due to distance from bodies of the Pacific Ocean largely. But I think this is a moderate. I wouldn't expect it to be a real late spring frost year. Growing seasons, again, looking at kind of the framework of where the climate structure is right now. If we look at analog years, growing seasons that have conditions like these right now all have a tendency to be warmer. There's no reason to believe that our general temperature framework or heat accumulation will be too far off what we've seen in the last few years in the West. And then lastly, I've said this a few different times, drought concerns are lowered for the Pacific Northwest into spring. I think this is going to continue. We're going to probably end up going into the growing season with some pretty decent soil moisture. California and the Southwest is likely to continue in moderate to extreme drought throughout the summer. So with that, I'd like to say thank you. I wanted to bring something up for everybody if you're interested. Up in the upper right-hand side of this slide, I have a website there for my monthly weather and climate reports. I've been writing these for 21 years now for the Western United States. They kind of started off at in a very Oregon-centric kind of view, but I've been, for the past 15 years, they've been very Western US oriented. And, you know, I write about kind of the same things we just talked about. What the month just was, what the season just was, what the current conditions are telling us, and then a forecast. So if you're interested in that, you can go find my most recent one there, but at the very bottom of that report, you can also submit a registration to get email notifications. So with that, I am going to stop sharing and open this up for questions.
We have a couple that came in already. Amanda Kemple asks, how do these trends compare to the Lewis-Clark Valley AVA up in Lewis?
So I think very similar. You know, if again, this past year, looking at what was happening in Eastern Washington as a good example, there was very interesting patterns that were developing where the west side of the Eastern Washington area, getting closer to the foothills of the Cascades, was actually a little warmer than normal, while the eastern side, moving more toward the Palouse and that area toward the Idaho border, was actually right at average to slightly cooler than average. So there's some very interesting things going on up there this year. And so I think that most of what I've just been showing you is probably pretty similar. I just didn't pull any data out for the the climate division. Matter of fact, I'm not, let me look and see what climate division that is. So you guys are up there and you're in climate division 2. And I just didn't pull data out of there. Sorry about that, Amanda.
No worries. I think we have another question from Jim Thompson. What would it take to turn the corner on the warming and start us into a cooler climate phase?
Oh, that's the $64 billion trillion question, however you want to look at it. You know, the climate system is it's something that there are numerous inputs that are going on. All of those inputs are, of course, solar radiation, aspects of how we modify the energy balance in the planet. And so we have a collection of issues between loading the atmosphere in terms of CO2, deforestation, desertification, urbanization. All of those things are inputs to making our climate system much more warmer and also I think highly variable. For us to start moving into a cooler climate phase, again, I'm not so sure we have the wherewithal as a society for us to be able to do the big scale things that need to lower our footprint on climate. In the meantime, we need to figure out how to adapt overall. I think that's probably the short-term solutions. The longer-term solutions are that we just need to be, number one, agriculture is part of the problem, but also part of the solution. We need to be better agriculturalists and storing more carbon in our soil and being able to be more resilient in the face of some of the things we've been seeing in terms of climate. I see that, okay, you got the link to the climate report in the chat.
Thanks, Moya, for doing that. Does anyone else have any questions? Give it a few more awkward silence seconds.
Yes. So I'll throw out a question for everybody. The most recent cold snap, was there any issues with potential damage at all? Winter freeze damage?
I know, like it'd be nice to hear from some of the growers. Actually, we have Mike Williamson on here. I need to put something on, or Jake. I know our blueberries were already starting to have buds swell, like because it had been so warm. So
yeah, I've heard of quite a bit of bud swell, but I mean, it was good. I think that we had this colder period. But you know what I think will be interesting this year? There will actually be more bud damage in Texas than there will be in Washington and Oregon and Idaho.
Well, I think how we were probably beneficial and saved is because we got snow too, with a blanket on, right? So yeah, I guess we're seeing where it says no damage.
Yeah, so temps into the 20s. Yeah, we ended up having a pretty severe ice storm here. I measured, I had, this is what weather and climate geeks do. When you see something coming, you put something in place so you can measure it. So I went out and I fixed a whole bunch of small measuring devices so that I could measure the ice accumulation. And the thickest I had on a branch was 2.1 inches. And but we had ice anywhere from 1.25 inches to 2 inches on many things in the North Willamette Valley, and we lost large number of trees here in the area.
Well, yeah, and I bet the weight could then like take them down, right?
Yeah. So Tim, you're saying at Emerald Slope Vineyards on the Oregon side, you haven't had any issues? But you did prune in the snow. I'd actually rather do that than prune in the rain I did yesterday. I got soaked. All right, I don't see anything else coming in, so I appreciate it very much. I will make a PDF of my presentation and share it with with Brenna, and she'll distribute it as needed.
Awesome. Thank you so much.
You're welcome. So can I stay around and listen to David?
Oh,
Yeah.
absolutely. Yeah,
Okay.
I think we're going to go ahead and let's do a 15-minute break and come back at 8:55. We're a little ahead of schedule, but David Wilkins is on the call, so I think we can just jump right in. So we'll see everybody at 8:55. Go refill your coffee.
Okay. Thank you.
Mm.